Hello, I'm David Hardy, and behind us here is mine and my wife's new house, and this is a passive house built to the German Passivhaus standard, which limits the amount of energy you use. In fact, it's quite often called the gold standard in terms of thermal performance. This is a brand new house built from scratch. We knocked down the previous building and started this about a year ago, and we're very nearly finished. As you can see, there's still some building work going on. But the principle behind what we were doing was that the house should be built to the Passivhaus standard, but also we wanted to make sure that the energy that we use would be replaced, at least if not in excess, by a degree of renewables. The design of the house is that we're facing due south here. The front of the house has much smaller windows. The back of the house, as you'll see, has large windows to take in as much solar gain as possible, but that's controlled to a certain extent by this lower rank of solar panels, which not only take in the sun's rays to help us produce electricity, but is also producing some shade, particularly during high summer, to limit the solar gain that we get inside the house. In addition to the solar panels and the general Passivhaus standard, we've got actually in the garden under here a rainwater harvesting tank, 3,000 litres, which takes water from every surface on the house, so including the solar panels, the roofs, the guttering leads into this tank. The principles of the Passivhaus standard dictate that the house is very well insulated, and this is achieved by a combination of things. So, for example, the floor is a raft of almost polystyrene. It's highly insulated, and then around the outside of the house the construction is a thin line blockwork, again very efficient at retaining heat. Again, the roof well insulated with a warm cell product, again very good at, it's almost like a duvet to sort of keep the house warm. Around the blockwork on the side of the house is actually another layer of polystyrene to act as a jacket, and then the whole lot is constructed in a way to achieve a level of airtightness. And by this fashion the house is able to hang on to accumulated heat for a much longer period than a standard build quality. The only sort of tangible bits you can see now that the house is finished is that here, for example, we've got triple glazing with very high or very low U values, and then the wall itself, you can see, is very thick, about half a metre in total, just over 200 mil of the thin line blockwork, and then around that another 300 millimetres of the polystyrene jacket. So this is the engine room of the house really, and up here all this ducting is the air intakes for the air source heat pumps here and here, and then more ducting for the mechanical ventilator providing the heating for the house. And then to look at these in order, this is an air source heat pump sitting on top of a 300 litre tank of water, and this provides us with our domestic hot water, so for kitchen usage, for showers, as I say, with its own air coming in, heat being removed from that, and used to heat this tank of water, and then we draw off that water as and when we need it. Behind it, exactly the same technology, another separate air source heat pump heating, on this occasion, a sealed tank of water. So this is a thermal store. We're not actually taking this water anywhere else, it's being used as a source of heat for this here, which is our mechanical ventilator. So this box is moving air from the outside into the house, around the house, and then back out. It's a mechanical ventilator with heat recovery, so it's, where possible, taking heat from places like the kitchen, showers in the bathroom, and using that heat to preheat coming into the house. And then where that demand isn't sufficient, the air handler has the ability to call on the heat from this store of heat in this water tank. And that gives us the only technology we have actually heating the house. So there's no other heat going around the house, it's purely ventilated air. Behind me we've got, this is the inverter for our solar panels, just the one inverter covering both arrays, 38 panels, and then next to that is some equipment including a box which allows us to actually monitor what's being produced and capture month on month what we're producing, exporting and using, so that at the end of the year and beyond I'll be able to know how much we've used or produced, and indeed know whether we've produced more through renewables than we've actually used in the house. This is a standard fairly dull consumer unit, but above it is another monitoring device, not a great thing to look at, but fundamentally this is monitoring individual circuits, so we know exactly how much power is being used by each individual circuit, and again at the end of a period such as a year we'll be able to know where we've used what power and on what items. And that's quite important because the Passivhaus standard says that you must only use up to a maximum of 15 kilowatt hours per square metre per annum in heating your airspace. This will actually let me know whether we've achieved that at the end of the year, and equally there's a limit on what your overall consumption can be, and again we'll be able to measure that. So as well as having at the beginning of the building process, or rather when you get to this stage, there is part of the certification that goes with Passivhaus is an airtightness test, which tells you whether the construction is up to standard. This equipment will let us know whether, once we've been living here for a year or so, whether the building is actually performing to Passivhaus standard, and that was quite key to our original thinking. The last bit of equipment in here relates to the lighting. The vast majority of the lighting in the house is LED, and what you're looking at here is all the individual drivers. Ordinarily these boxes would sit in the ceiling above the light, but to have the opportunity to, while building from scratch, to design it differently, all the LEDs are here, and a slightly different coloured bank at the top are separate drivers that allow us to have some of these circuits operated by a wireless switch rather than your standard direct rocking switch on the wall. But it just makes for a much more efficient presentation and much easier maintenance. In the utility room we talked about the mechanical ventilator with its heat recovery, and that heat recovery is based on taking warm air that's produced from the kitchen or indeed from the bathrooms. And above us here and on my head here are two extractor points where the air is taken out. But elsewhere in the house, for example the living area at the bottom end of this room, you'll see there are two other vents, this one here and the one behind me. These are pumping air into the room, so you have circulation of air going around, and as I said earlier, that's how the house is heated, and it's the only way the house is heated, and it works extremely well. Well, I hope that's given you a feel for what a Passivhaus is about, and we're actually opening the house as part of the Cheltenham Green Doors event later in the year, and clearly that's an opportunity for members of the public to see what's here, and indeed ask more questions about how the house works, how we came to be building what we've got, and anything else of interest.